Imagine walking on a vast, open plain, the wind gently pushing against your face as it sweeps across the landscape. In the distance, you see the towering figure of a wind turbine, its colossal blades slicing through the air with effortless grace. This modern marvel is not just a static monument but a dynamic machine converting the wind's kinetic energy into electricity that powers our homes, schools, and businesses. But how exactly does this transformation occur? At its core, a wind turbine works by harnessing the natural motion of the wind. The wind's kinetic energy is converted into mechanical energy, which is then transformed into electrical energy. Let's delve into each step of this fascinating process, unraveling the story of how the wind's invisible force becomes the electricity that lights up our lives. The journey begins with the wind turbine's most iconic component, the blades. Modern wind turbines typically have 3 blades, designed with aerodynamics in mind. These blades are shaped like airplane wings, with one side curved and the other side flatter. This design creates a pressure difference when the wind blows, causing the blades to lift and rotate. This principle is similar to how airplane wings generate lift. When the wind blows, it exerts a force on the blades, causing them to spin around the rotor. The rotor is the central hub where the blades are attached, and it is designed to capture as much wind energy as possible. The speed at which the blades spin depends on the wind speed. Stronger winds lead to faster rotation. This rotation is the first step in converting the wind's energy into usable power. As the blades spin, they turn the rotor, which is connected to a low-speed shaft. This shaft rotates at the same speed as the blades, typically around 30 to 60 revolutions per minute, RPM. While this speed might seem slow compared to other mechanical systems, it's just the beginning of the energy transformation process. The low-speed shaft is connected to a gearbox, a crucial component that steps up the rotational speed. Think of the gearbox as a mechanical amplifier. Inside the gearbox, a series of gears increases the rotation speed from the low-speed shaft to much higher speeds required for electricity generation. This conversion is necessary because the generator that produces electricity operates efficiently at higher speeds. For example, if the low-speed shaft is rotating at 30 RPM, the gearbox can increase this speed to 1,500 RPM or more, depending on the design of the wind turbine. This significant increase in rotational speed is critical for the next stage of the process. Once the rotational speed has been amplified, the energy is ready to be converted into electricity. The high-speed shaft coming out of the gearbox is connected to a generator. Inside the generator, a magnet and a coil of wire interact to produce electricity. This process is based on the principles of electromagnetic induction, discovered by Michael Faraday in the 19th century. As the high-speed shaft spins, it turns the magnet inside the generator. The rotating magnet creates a changing magnetic field, which induces a flow of electric current in the coil of wire. This current is the electricity that will eventually be used to power our homes and businesses. Modern wind turbines are equipped with sophisticated control systems that ensure they operate efficiently and safely. These systems monitor various parameters, such as wind speed and direction, and adjust the turbine's orientation and blade angle to capture the maximum amount of wind energy. For example, if the wind changes direction, the control system can rotate the nacelle, the housing that contains the gearbox, generator, and other components, to face the wind. This adjustment ensures that the blades are always positioned to capture the most wind. Additionally, the control system can change the pitch of the blades to optimize their angle relative to the wind, further enhancing energy capture. Once the generator produces electricity, it is sent through cables down the turbine tower to a transformer. The transformer increases the voltage of the electricity to make it suitable for transmission over long distances. This high-voltage electricity is then fed into the electrical grid, where it can be distributed to homes, businesses, and industries. One of the most compelling aspects of wind turbines is their environmental impact. Unlike fossil fuel power plants, Wind turbines generate electricity without emitting greenhouse gases or other pollutants. This clean energy source helps reduce our reliance on fossil fuels and mitigates the effects of climate change. The story of how a wind turbine works to create electricity is a testament to human ingenuity and our ability to harness the natural forces of the earth.